Welcome! Today we'll find the second derivative of y equals tangent x plus secant x through a step-by-step process. Let's start by rewriting this expression in terms of sine and cosine. Remember that tangent x is sine x over cosine x, and secant x is 1 over cosine x. Now, to find the first derivative, we'll use the quotient rule. The quotient rule states that the derivative of u over v equals v times the derivative of u minus u times the derivative of v all over v squared. Let's apply this to our function. Here, u is sine x plus 1, and v is cosine x. The derivative of sine x plus 1 is cosine x, and the derivative of cosine x is negative sine x. Substituting these values in, we get cosine x times cosine x minus sine x plus 1 times negative sine x all over cosine squared x. Now, let's simplify this expression. In the numerator, we get cosine squared x plus sine squared x plus sine x. Remember that sine squared x plus cosine squared x equals 1. So we can simplify this to 1 plus sine x over cosine squared x. For the second derivative, we'll differentiate this result, again using the quotient rule, but this time with u equals 1, and v equals 1 minus sine x. The derivative of 1 is 0, and the derivative of 1 minus sine x is negative cosine x. Substituting these values and simplifying, we get cosine x over 1 minus sine x squared. And there we have it. The second derivative of tangent x plus secant x is cosine x over 1 minus sine x squared. This problem demonstrated the importance of knowing your trigonometric identities and being comfortable with the quotient rule for derivatives. Thanks for watching.